Hi, what we're going to learn today is perpendicular and angle bisectors. So some background information because we have seen these before earlier in the year. Two things that a perpendicular bisector segment does is that you have a midpoint. It creates a midpoint and it has 90-degree angles. So here's our segment. Let's say that's a side of a triangle. We draw our perpendicular bisector so it forms that 90-degree angle and acts as a midpoint. An angle bisector cuts angles into two congruent angles. Okay, so we have seen these before. So here's our angle. Our angle bisector always starts at a vertex, comes out, and now makes that two congruent angles. So what we're going to talk about today is perpendicular bisector and angle bisector. Now, a perpendicular bisector is a segment, ray, or line that is perpendicular to a side of the triangle at its midpoint. So I'm going to do a perpendicular bisector to this side, which we would make the midpoint, and then we have to draw a line that's perpendicular to that. Now notice how it doesn't start at one of the vertices, the opposite vertice. That is okay. Okay, so if you look at the facts, it says does not necessarily go through a vertex of the triangle because we have to create that 90-degree angle. In an angle bisector, again, we're going to start at a vertex, and then we're just going to go across, creating two congruent angles. So some things we need to know, again, that perpendicular bisectors do not necessarily go through a vertex of the triangle. There are three perpendicular bisectors, so every single side has one. And that every point on the perpendicular sector is equidistant to the endpoints of the side of the triangle. So let's say this is that side of the triangle we just drew up top. And if we were to draw that perpendicular sector, which means it makes the perpendicular line, we know these are congruent. That's our perpendicular bisector. But if I were to draw any point on and connect those endpoints, you would say those two are congruent. Now I can do that with any point I draw. So if I draw one all the way up here, I could say those 2 points are sides are congruent. The same thing goes for an angle bisector, but it's just a little bit different. So if we draw our angle bisector, any point on this sector, okay, I'm going to draw a point here, is equidistant from the sides of the triangle. But what also happens is that they form 90-degree angles with that sector. So if you were to draw in those two lengths, they have to form 90-degree angles. So let's try a few examples. So it says given AB is perpendicular bisector to triangle ARC, we know that we form a right angle and we know these are congruent. Now notice how this point here is on the sector. Therefore, we can say these two sides are congruent. Okay, that's only if it's on the sector. So to find the value of x, you would take those two sides AR and set it equal to AC, 9x minus 12. So we would go through and solve, and you have 9 equals 7x minus 12. Add 12, so you have 21 equals 7x, and x equals 3. Now we need to find y, and y is the midpoint section, so we would say, we know they're congruent, so you would set them equal. 3y is equal to 24 minus 9y. Add 9y, and you get 12y is equal to 24, or y is 2. Now the last one is z. If you notice, z is one of the angles, so that should have a degree symbol here, right? So we know that when we have something equal to 90 degrees, we can set it equal to 90. So 5x plus z is equal to 90. We know what x is, so we can go ahead and substitute that in and solve. So 15 plus z equals 90. And if you subtract 15, you have z equals 75. Now what about an angle bisector? We're given that GH is an angle bisector of angle JGK right here, so we know that these two parts are congruent. I need to find JH and HK. Now notice how these lines are drawn. We know that they are congruent now and form 90-degree angles. So we're given JH and KH. So knowing that those are congruent, we can go ahead and set those equal. The other two are there really just to throw you off. So we would subtract x, and you have 2x minus 2 equals 44. Add 2, so 2x equals 46, and x equals 23. Okay, so I didn't ask for x, I asked for JH and HK. So you can take that 23 and substitute it into one of those two, because again we know they're congruent. So you would have 69 minus 2, or 67. So you can say JH is 67 and HK is 67. Now the next question, part B, says if the measure of JGK is 28, so this whole thing is 28, I want to know the measure of KHG, this one here. So how do I figure out? I know I have one 90-degree angle. I need to find another, so how do I find this third one? Well, if this is an angle bisector, then all you have to do is divide that 28 by 2, so this small measure here is 14. So you know a triangle has 180 degrees, minus that 14, minus the 90-degree angle, and that gives you the measure of angle KHG, which is 76 degrees. You can start your homework. If you have any questions, raise your hand. I'd be happy to help you.